As we all know, there are some basics of magnets. Magnets have north and south poles. Next, two of the same poles will repel each other, while opposite poles will attract each other. Only certain materials that contain iron can be magnets, depending on their molecular arrangement. Other metals such as cobalt, nickel, iron, and steel are attracted to magnets even though they are not magnets themselves. Just as we use electric field line to represent the electric field created by charges, we can also draw magnetic field lines to represent the magnetic field created by magnets. A magnetic field is the region around a magnet where a magnetic force can be experienced. We measure magnetic fields using a unit called Tesla. As soon as the current flows through the wire, orientation of the compass needle changes from the north and points toward the different direction at different positions. The magnetic field is produced due to the motion of electric charges. When electric charges move, they are surrounded by both an electric field and a magnetic field. A magnetic field can be produced by a current carrying conductor, and the lines traverse the wire either in a clockwise or counterclockwise direction, depending on the current flowing through the wire.
Now, we want to conduct one of the example of magnetism experiment that we can observe. The materials that we need are a piece of paper, a magnet bar, and the iron filling. First, we place the paper on the flat surface. Then, place the magnet on the paper. Lastly, to observe the magnetic field, we sprinkle the iron filling around the magnet. We can see the pattern of magnetic field. If you look at the pattern, you can see that the iron fillings have arranged themselves in curved lines that originate from one end of the magnets and terminate at the other. Also observe the concentration of the lines is more at the pole of the magnet. Most of the lines run from one pole to the other. If we draw a diagram of this on a paper, it will look like this. The long curved lines shown along a magnet are the magnetic lines of force. They run from North Pole to the South Pole. The space in which lines of force are spread around a magnet is called magnetic fields. The characteristics of the lines of force are the attempt to form closed loops from pole to pole. They never intersect and they all have the same strengths.